Now that we are done with the algorithms, we're going to see how to use a programming language to code your solution. To do so, we are going to start with these coding and validation steps, explaining how to execute and test your program, and then put some documentation in it. In the last video, we have seen that it is important to analyze your problem, decompose it, and write down an algorithm. The 3 steps represent the logic of programming. Now we are going to finish the whole process, the whole workflow, explaining the coding and the validation. These 2 steps, as explained before, concern the programming side or the coding side. What does mean coding? It means converting the algorithm in a computer language. Remember, the algorithm is not something that will be input in your computer. It is something you are going to write down with a sheet of paper and a pen. But when it comes to instruct the computer, you need to use a computer language and convert or code your algorithm into a programming language. Then comes the validation steps, consisting in testing the program, the code you have written, and using some test cases to see that it works fine. We are going to consider again our very simple example in which I am adding here 2 other statements to display to the monitor to ask the user to type the value of X, reading the X, asking the user to type the value of Y, reading the value of Y, and then computing the sum, and finally displaying the sum. So here is a program or an algorithm consisting in 1, 2, 3, 4, 5, 6 statements. Now I am explaining the coding and validation. We are going to see how to convert it. So the conversion consists in translating the algorithm into the programming language of your choice. So if I take again this very simple algorithm, many programming languages are available today, such as C, which is the programming language that we are going to study in this course. You have also Java, Python, JavaScript, and many other programming languages that are available. What does it mean now? You can switch on your computer and start coding, because you analyze the problem, you decompose it from the general to the different small steps. You are ready to convert it to your programming language. So let's see, for instance, the conversion to the C language. So C language starts with the inclusion of some libraries. I'm going to explain this in other modules later on. We write what we call the main program, and here I declare the 3 variables X, Y, and Z to be of type integer. Then instead of saying display in C language, we say printf, type the value of X. So you see here that the translation instructs that the display as an algorithm is converted into printf in C language. Then I read the variable using this new order, this new statement in C that we call scanf. Again, I'm going to do the same with the variable Y, and then I will compute the sum and then displaying the sum using the printf, and here ends the C programming language. A C programming language, it's not the same syntax, it's not the same statements, but the logic remains the same. If I provide this program to someone that knows only, for instance, Python, it's much easier for him or her to provide him with the algorithm that is ready to be translated to any other programming language. So let's see, for instance, the conversion to the Java language. Again, I am importing some libraries. This will be discussed or learned in other courses, such as the Java language course. I declare the main body of my program, and then I declare, as I previously did in C language, and you see here it's not the same as in C language. I display, type the value of X, I read the value of X. You see here that this depends on the programming language. From C to Java, it's not exactly the same. I do the same with the variable Y, and then I compute the sum, and then I display again Can you guess what display Z will be replaced with in Java? Yes, the same one as the one I have here, system.out.print, the value of Z is Z. And then I am done with my program. So pretty much there are some common statements between Java and C, but not all of them. Now, if I would like to write it in Python, you will see that it's a bit different to convert my program in Python. So displaying means, or asking to read, type the value of X, and then I read the value and I put it as an int to the variable X. I do the same for the variable Y. It's much compact in Python if you compare it with others. But you might be familiar, or you might be more interested to know Python rather than other programming languages. It depends on the problem in hand. It depends on your experience in which language you prefer to code with. Then I compute the sum, and then I finally print the value of Z. So you see pretty much it's the coding from the algorithm to the programming language. So the conversion is done according to the language of your choice. But remember, the algorithm does not change. Any computer scientist all over the world is supposed to know how to read and how to convert it in the programming language he or she prefers the most. Now, after the conversion come the execution and the testing. What does it mean now that it is input inside the computer in some programming language? So now the computer is able to execute it. So for instance, we execute and test to see if my algorithm and therefore my program is well written, there is no error, and I'm able to execute the program. This is what appears on the monitor of your computer. So the message type the value of X is written, and then the computer waits the variable X to be read from the keyboard. So you see here that the computer is waiting for you to type something on the keyboard. Now suppose we type something, in this case suppose we type 5, then again the machine or the computer displays this message, type the value of Y, and again expects the user to type the variable of Y. That's why it gives you this input text to type something. And suppose we have typed 8, then the sum is executed, and then the message is displayed at the end to give us the value. So this is one possible execution. Let's take another execution. So for instance, instead of typing 5, we type 35 for the value of X. Then we type -4 for the value of Y. Then the sum of 35 and -4 is 30. So those are examples of executing your programming after having converted it to your programming language. The one final step, which is of really very important, is to add some documentation. Considering again the program of C language, but you can see here that the number of statements have increased, but in the green color. These are considered not part of the program itself, but only a sort of documentation. This documentation, the purpose of them is to add an explanation in the code. You can see here that in the case of C, they start with // and you can see here that I'm writing in English. The aim of this program is to calculate the sum of two variables. There is some mistake here, no problem, because it's only in English. You can write what you want to write. It only explains to another user that is interested to read your program what the program is about. It explains the different parts you have. So for instance, here I declare the input and output variables. I read the value of the first variable. I read the value of the second variable. I calculate the sum and assign this sum to the output variable, and then I display the value of the output variable. So you can see all these are given in English to explain to anyone, to any other programmer, what the program is about. Here it's basic, but you can imagine, for instance, that you have programmed something like Microsoft Word, like Google Google Map, for instance, is a huge program, and then we need some documentation to give the opportunity to any other computer scientist to read and understand if he needs to do something similar or if he needs to update the program, which means that this documentation, these sentences, these comments are computer non-understandable. The computer does not, it ignores these documents or these comments, okay? It is user understandable, of course. It is intended to be understood by the user. Of course, it increases the number of lines, for sure, because we add some new statements that the computer will ignore, but it helps the understanding, it eases the user reading of this program. As a summary, we said that this lesson, we saw that at the end, after analyzing and writing down the algorithm, it is time to translate in a programming language. We have seen that it is important then to test my program when it is written in your computer and see multiple use cases. And then don't forget to add documentation to ease the reading and the maintenance for the update, for the correcting some errors you might have, etc.